Troubleshooting the Solaire furnace. The Solaire furnace is new on 1975 GMC Motorhomes. It is considerably different from the furnaces previously used because it uses spark ignition rather than a pilot light. So its control system is all new. Something else that is new is that it uses a plenum and cold air ducts for air circulation throughout the motorhome, so its installation is different as well. As you'd expect, servicing the Solaire furnace is different too. But before we cover trouble diagnosis, let's first take some time to see how the furnace works. The main components of the furnace are the heat exchanger, which is heated directly from the flame rather than by heated air, and the burner, which mounts on the end of the heat exchanger and has a forced air inlet fitting for combustion air. The igniter fits into the burner, and it operates very much like a spark plug. However, it fires continually. High voltage spark is supplied from the ignition pack, a sealed unit which does the same job as the coil and distributor on a gasoline engine, but with only one high-tension wire to the igniter. The automatic gas valve is solenoid operated, and it opens to admit gas to the burner when the blower is up to speed. The blower assembly contains two blowers driven by one motor. The main blower provides for circulation of air in the motorhome. The combustion blower force feeds the burner through an air tube to improve the efficiency of combustion and increase the furnace's heat output. The blower assembly also includes a centrifugal switch, which closes to energize the gas solenoid valve only when the blower is up to speed. The control box has thermostat and power connections at the top and connections to the other components at the side. They are clearly identified to correspond with the wiring schematic. Inside are four relays: the auxiliary blower relay, the start relay, the run relay, and the thermal reset relay. The thermal reset relay is one safety shutoff device. Another safety shutoff is a conventional high-limit switch. It will open the solenoid valve circuit if the heat exchanger gets too hot and close it again when it cools. The thermal relay trips a reset and shuts the furnace down if the furnace doesn't fire for any reason, or if the high limit switch isn't working and the heat exchanger gets too hot. The electric control system also includes a fuse for overload protection, which is part of the control box, and a flame rod switch installed in the burner. Now, let's see how the furnace works by explaining its three operating cycles: the start cycle, run cycle, and purge cycle. This is the wiring diagram for the furnace. Terminal and wire numbers are marked to correspond to the numbers on the control box and the flags on the wires. The start cycle begins when the thermostat closes, calling for heat from the furnace. Power is supplied through the fuse, the thermal reset relay, and the thermostat switch to energize the start relay and close its contacts. With the start relay closed, power goes through the high limit switch to the blower centrifugal switch, which you'll remember controls the gas valve. Power also goes through the run relay, which is normally closed, to the heater in the thermal reset relay, to the ignition pack, to the auxiliary blower relay, and to the blower motor. Then the blower starts to run. When the blower reaches a certain speed, the centrifugal switch closes to energize the gas valve solenoid, and the furnace fires. That's the start cycle. The run cycle begins about 10 or 15 seconds later, when the flame rod warms up and closes the flame switch. This energizes the run relay coil. When the run relay is energized, power is cut off to the thermal reset heater, but continues to the blower motor through a set of normally open contacts. For the furnace to operate on normal run, both the start and run relay must be energized. Now, when the temperature in the coach builds up and the thermostat opens, the furnace goes on the purge cycle to cool the heat exchanger. So the start relay is de-energized, and this cuts off power to the solenoid on the gas valve. The blower, however, continues to run as long as the run relay is made. Then, when the flame rod cools, it opens the circuit to the run relay and shuts the blower down. And that's the normal furnace cycle. Let's see what can happen now if something goes awry. Suppose the furnace doesn't fire for some reason. Remember, in the start cycle, we're applying power to a heater coil on the thermal reset relay. If the burner doesn't come on, or if we have a poor flame, the flame rod doesn't heat up, or it heats up slowly. That delays the energizing of the run relay. And about 35 to 45 seconds after the start relay comes on, the heater warms the thermal relay enough to pop the reset. The unit is shut down. Incidentally, the same thing will happen if the input voltage is low or the blower runs slow for any other reason. The centrifugal switch will open, the gas will shut off, the flame rod will cool and open the run relay, and the thermal heater will warm up and pop the reset. With that in mind, let's see what to do. One of three malfunctions may occur when the thermostat calls for heat. The burner may fail to light, or it may light but the reset pops in a few seconds, or the blower may not start up. We'll take the problems one at a time. However, before you start your trouble diagnosis, there are two external conditions that must be met. First, there must be 12 volts, absolutely no less than 10.5 volts, into the furnace with the furnace on. And there must be 11 inches of gas pressure available, measured at the kitchen range. Here, we're going to demonstrate troubleshooting procedure on the bench so you can see things more clearly. The preliminary checks in each case, however, can be done in the motorhome. To begin to troubleshoot the furnace, first set the thermostat to call for heat. Watch for a flame in the sight glass and listen for the blower to start up. You will determine what the actual malfunction is by what you observe. The burner does or does not light, the blower does or does not start. The first furnace problem we'll cover is the situation when you observe that the burner won't light, but the blower does start up. First, check the furnace for spark. Turn off the manual gas valve on the furnace for safety during the check. Be sure the ignition high-tension wire is connected securely in the ignition pack. Remove the locking nut from the igniter and pull the igniter out of the burner. Using insulated pliers, hold the igniter about 1/2 inch from the burner. Then turn on the thermostat. There should be a bright, continuous spark at the igniter tip. If there is, the spark system is okay, and you next check for gas flow through the furnace. A little later, we'll tell you what to do if there is no spark. Before you check for gas flow, turn off the thermostat, and if the reset has popped, press the button to reactivate the furnace. Replace the igniter and turn the locking nut finger tight. It's not designed for over-tightening. Remove the spark wire and tape it out of the way while you check for gas flow. Turn on the furnace's manual gas valve to feed gas to the furnace. And turn on the thermostat. Walk outside the coach. You have about 30 seconds before the reset pops. And smell for LP fumes at the exterior right-hand furnace vent. If the solenoid gas valve opens, gas will flow through. If you don't smell gas, it's because the solenoid gas valve didn't open. We'll see what to do about that in a minute. Now, if you have a spark, and if gas flows through okay, the reason why the burner won't light is because the primary air adjustment is too lean. To fix it, loosen the hex lock nut slightly and turn the adjusting screw counterclockwise to the full rich position. Start the furnace by setting the thermostat to call for heat. Then watch the burner through the sight glass and turn the adjusting screw until you see a slightly yellow flame with green cones at the ports in the burner. Turn the screw a slight bit further so that the yellow disappears and the cones are sharp and blue. That is the correct adjustment, so hold the adjustment with the screwdriver while you tighten the hex nut. One important word: the total adjustment travel is only a few degrees, so don't twist the screw past either stop or you'll have to replace the burner. As we said before, if you don't smell gas through the furnace, it means the solenoid gas valve didn't open. To find out why, check for voltage to the solenoid valve. Take the voltmeter reading with the furnace on and the blower up to speed. If you have 12 volts to the valve and it doesn't open, replace the valve assembly. If there's no voltage to the valve, you'll have to pull the furnace from the vehicle to find out why. On the bench, as we've done here, connect a 12-volt supply to the furnace power terminals on the control box. Use a jumper wire across the thermostat terminals to start and stop the furnace. Now, remember that the solenoid gas valve is fed from the centrifugal switch on the blower, and that feed is from pin 11 on the control box. So measure the voltage at pin 11. If you get 12 volts at pin 11, but can't get voltage to the gas valve, the centrifugal switch is bad. You then have to replace the blower assembly. If there's no voltage at pin 11, check the voltage at pin 8 to ground to be sure there isn't an open high limit switch. If the switch is okay, but you can't get voltage to the circuit, replace the control box. Let's backtrack now to our original checks in the coach. Let's see what to do if there was no spark at the igniter tip. There are several checks that can be made with the furnace installed. First, be sure the ignition pack ground wire has a good connection at both the ignition pack and the burner housing. Also, check for proper polarity at the pack. The red, hot wire must be at the left, and the black ground wire at the right. With the thermostat on, see if you have 12 volts at the ignition pack. If you don't, pull the furnace for bench testing. The ignition pack is fed from terminal 12 on the control box, so check for voltage there with the furnace turned on. Incidentally, to turn on the furnace while it's on the bench, just short together the two thermostat leads. If there's 12 volts available at terminal 12, repair the red or hot wire to the ignition pack. If there isn't 12 volts, replace the control box. And that covers the condition where the burner doesn't light, but the blower runs. Next, let's take the situation where the furnace fires, but the reset pops in less than 1 minute. Remember that the flame rod circuit should energize the run relay within 10 to 15 seconds after the furnace fires, and energizing the run relay bypasses the thermal reset heater, so it can't shut down the furnace. Trouble diagnosis, therefore, is aimed at determining whether the problem is the control box or the flame rod circuit. When you start your diagnosis, be sure to give the relay time to cool. It may take as long as 3 to 5 minutes. Then, press the reset and turn on the thermostat. Check the time it takes for the reset to pop. If it's less than 35 seconds, the thermal relay is defective and you'll have to replace the control box. If it takes 35 to 45 seconds to shut down the furnace, check the flame rod circuit. So let the reset cool and then push it again. Remove wire number 9 at the flame rod switch and connect an ohmmeter across the terminals. Turn on the thermostat. The resistance of the flame rod switch should go to about 0 ohms within 10 to 15 seconds after the furnace fires. If it doesn't, replace the flame rod. If the flame rod checks OK, jump terminals 9 and 10 on the control box to bypass the flame rod circuit and see if the box is all right. If the furnace operates OK with the terminals jumped, it means the flame rod wiring is defective and you'll have to repair it. If not, replace the control box. That's how to solve reset popping problems. The final problem we'll cover is a furnace with a blower that fails to start up when the thermostat calls for heat. Obviously, the first thing to do is press the reset. If the furnace runs, you're all set. If not, check the fuse. It may have blown from a surge of current. If necessary, install a new fuse. If the new fuse blows immediately, pull the furnace to test the control box, which we'll cover in a minute. If the fuse checks OK, next connect a jumper across the thermostat leads to the furnace. If this starts the furnace, repair the thermostat wiring or replace the thermostat. If jumping the thermostat doesn't make the furnace run, pull the furnace for bench testing. To locate the cause for no blower operation, connect a 12-volt supply across terminals 5 and 11 on the control box. Be sure you're on 11 and not 12, and see if the blower works. If the blower runs, you have a bad control box and you should install a new one. If it doesn't run, replace the blower assembly because it's defective. What do you do if fuses are blowing continuously? First, disconnect the wires from terminals 11 and 12 on the control box and connect power to the power terminals. This will take the ignition pack and blower assembly out of the circuit. Install a new fuse. Jump the thermostat terminals and see if the fuse blows. If it does, the control box is defective. If the control box is OK, reconnect the wire to terminal number 12, the blower circuit, and see if the fuse blows. That would indicate the ignition pack is shorted and needs to be replaced. If the fuse doesn't blow, you can conclude that the blower assembly is defective and you'll have to install a new one. That's how to trouble diagnose the Solaire furnace. Review this film again and follow the approved procedures in the maintenance manual and dealer service information bulletin for fast, accurate servicing.